Right. In this video, we will be discussing the Bluetooth module HC05. First, let's have a look at the serial monitor. So here is some code. What this code does is that it allows me to turn on and off the LED at pin 13 from keyboard commands. Meaning if I tell it to turn on, it turns on. When I tell it to turn off, it turns off. Right. So first I just put a define and I've declared two globals, one message pending and one pin state. So first I start the serial monitor. I set that LED pin as an output and I set message pending as 1. So message pending is what is known as a flag variable. A flag variable is whatever we use in order to track the state of some code. It's typically just a boolean, a 0 or 1. Don't worry too much if you didn't understand that definition. For flag variables, showing how it works is better than telling. So if message pending is true, that is, if there is a message pending, if the message is not being printed, let's print it. So serial.print, enter 1 to turn LED on or 0 to turn LED off. So this is printed to the serial monitor. Message pending is equal to 0. That is, we have printed the message. So assign 0 to message pending. Now on the other hand, if there is no message pending, that is message pending is equal to 0, if serial.available, if there is some input available at the serial port, pin state is equal to serial.read minus 48. So this whole segment over here is like scanf. This is like printf. However, since it is a multi-device connection, we have to first check if a message is available and then read it. So if there is some message available at the serial monitor from the user's side, read that message. So here, this returns an integer, which is the ASCII corresponding value of the first character in the user message. So it reads byte by byte. So why am I subtracting 48? Precisely for that reason. The ASCII value of 0 is 48. So if I didn't have this minus 48, pin state would be holding 48. I want pin state to have either a 0 or a 1. So I am subtracting 48. So basically when the user inputs 0, what would be stored is 48. Instead, I want 0 to be stored. So I am subtracting 48. Now if pin state is 1, if the user inputted 1, set the pin to high. So a message is printed turning LED on. We write that LED to high and set message pending to 1 again, so that next time it loops around, we print the message again. Else if pin state is 0, same thing, turning LED off, write that pin state, message pending is equal to 1. Let's just see this in action first. So connect your board, upload this code. You do not need to connect anything other than the computer. So let's launch the serial monitor and a message shows up. Enter 1 to turn LED on or 0 to turn LED off. Now observe the board. If I just give it a 1, it turns on. If I give it a 0, it turns off. If I give it a 1, it turns on. Give it a 0, it turns off. Great. So let's go back to the code now that we understand it. In summary, we define some things. We set up the pins. If we have printed that message, just wait for user input, take that input and process it. If we have not yet printed the message, which is this message here, print the message, and then on the next loop, we wait for user input. Great. So now we know how to use the serial monitor. So now we are ready to actually talk about the Bluetooth module. For this next part of the tutorial, you will need a different kind of serial monitor. We can call it a serial monitor. We use it for other things as well, but right now we are going to use it as a substitute for the serial monitor. One of the failings of this Arduino web editor is that I can't seem to get it to accept connections using Bluetooth. So we use a different kind of serial monitor. So the software you need is called Putty. P-U-T-T-Y. So first, connect your Arduino board through the USB. Ignore this. Go to the device manager. Go to ports. Ignore these two. Have a look at USB serial device, COM3. For me, it is on COM3. So go here, serial, COM3. Open. The same behavior can be seen here. So 1, 0, 1, 0. Let's close this now. Getting back to the Arduino board, USB is not the only way of connecting to it. It's just one of the ways of connecting to it. What I'm trying to say is that as far as this microcontroller is concerned, all this business on the serial monitor, it's not happening through the USB port at all. Internally, it is a serial port. And the USB port is just one of the many ways of accessing the serial port. The other way of accessing the serial port is through this over here. Pins 0 and 1. You can see this marking here, TX and RX. And that corresponds to these bulbs here, TX and RX. When it is transmitting something and when it is receiving something, those bulbs glow, which is why you saw it when we were working with the serial monitor. Right? So what this means is, if we connect a suitable device through TX and RX, the Arduino board will accept it as a valid substitute for the USB. As far as the Arduino board is concerned, you haven't done anything different. You have connected another serial device, and if the device communicates properly, it will behave in exactly the same way. Whether it is through USB or through these two here, it doesn't matter. If the device communicates properly, identical code should give identical results. That's what I'm trying to say here. We have already written code which uses the serial monitor and runs with this system here. We just used it to turn the LED on and off. So if what I have said so far is true, that same code should work without the USB connection if we connect a suitable device at pins 0 and 1. That device is this, the HC05 Bluetooth transceiver. So it has 4 pins. So it has 4 pins: RXD, TXD, ground, and VCC. So this connects in there. So VCC and ground are obvious. RX and TX connect to this 0 and 1 over here. Right. So let's make the connections. There is one mild complication to this. Power is, it accepts 3.6 volt to 6 volt. So our 5 volt line from the Arduino board should work just fine. However, the level of the signals RX and TX is 3.3 volts. So if we give it something higher than 3.3 volts, we risk damaging the board. So we need to make a small potential divider. Right. So everything we need is here. We have the board, we have the breadboard, we have the Bluetooth transceiver, and we need 2 resistors. I have 2 resistors over here. One is 22 ohms, the other is 33 ohms. So a 2:3 ratio seems to be working fine. Right. So let's make the connections. First I'll mount this over here. Next is to connect the 5 volt line. Since the only thing using the 5 volt line is this itself, this Bluetooth module, I can connect it directly. Right? Next, ground. Because multiple things will use ground, as you'll see in a moment, it's better to connect ground to a rail. In general, it is better to connect to the rails, but too many wires for this video. Next, connect that to ground. VCC and ground. Yes. Next we have TX and RX. So this is where the potential divider comes in. So take the 33 ohm resistor and connect it to ground. Next, take the 22 ohm resistor and connect it to another line. And one end of the 22 ohm resistor should be to another line. The other end of the 22 ohm resistor should be at the same line as the 33 ohm resistor. Now connect the other end of the 22 ohm resistor to TX on the Arduino board. Connect this third point on the rail to RX. Very important. TX on Arduino goes to RX on the Bluetooth board, and RX on the Arduino board goes to TX on the Bluetooth board. Now we can directly connect RX of the Arduino board with TX of the Bluetooth board. These are the connections. Now comes the moment. So just connect, not to your USB now. Connect the USB to a wall charger. Say your smartphone charger. Right, it's supposed to do that. So, first, show Bluetooth devices. Let's suppose I remove that. So, for the first time if you're connecting, add Bluetooth or other device, Bluetooth, HC05. It will ask you for a pin. Usually that is 1234 or 0000. And we have connected. Next, go to devices and printers, properties, services, serial port on COM4. Alright, remember that it's on COM4. So now we launch Putty. Serial COM4. Open. If your LED on the Bluetooth module has stopped flashing at that alarmingly high rate, then it means you've done it right. Now, press the reset pin on the Arduino board. And it worked. If you recall, I asked you to connect the USB not to your computer but to a wall charger, and that is what is happening right now. Right. So this was the Bluetooth module. Using this and using Putty, hopefully you have everything you need to make your own Bluetooth controlled car. Yes, you can make your own Bluetooth controlled car now. Just figure out how to do it. You could probably use ASDW and use the ASCII values from there. You will have an if loop of some sort. You'll have, if statements in a while loop, and you can work with that. With this, we have covered all the modules in Arduino.